We are starting with graphing equations with sine and cosine. We'll eventually be doing the other 4 trig functions as well, but they're all sort of based off of this. This is going to take us like 4 class periods to really get good at all the pieces that go into this. And then we will be looking at inverse trig functions, and then we'll be at our test. So we're about halfway through the unit at this point. The way that I teach this, and I have taught this since I first started teaching pre-calculus, is more of like a engineering view of this topic. So there's sort of like the pure math way of looking at things, where like we're going to look at functions and look at the different transformations that we do to functions like we did in the first semester. We're not going to treat this that way. We're going to do it sort of backwards. That's going to get us some nice graphs, and this will be very usable to us when we get to some application problems. But I do promise you that later on, after we've had a couple lessons and we're getting comfortable with this, we'll circle back and we'll talk about sort of the pure math side of it as well. Okay. So a fair warning, I'm gonna lie to you a little bit today. I'm not like trying to mislead you, but I'm gonna hide some stuff from you just to kind of keep things on the easy side for today, and then we'll kind of uncover some of those things later on. This happens a lot in math. You guys were told for many years you couldn't take the square root of a negative number, right? So it's not that we were trying to hide it from you. It's just why deal with that stuff? So, okay, so here we go. A little bit of vocabulary for you. Let's talk about the equation first. This coefficient that sits in front of your sine or cosine is called our amplitude, and we usually denote it with an A. And that shows up on our graph right here. The coefficient that goes in front of the x is omega. It looks like a lowercase w, but it's a little bit more rounded, and it's not a w, it's the Greek letter omega. And omega is related to the period. So the period of the function appears on the graph right here. It's the length of it, horizontal length of it. We denote that with a capital T. I believe they use T because in a lot of applications, the x-axis will be representing time. All right, and there's a couple important formulas we need to know to relate omega to t. So we can't look at the equation and know what the period is. We have to do some work with it. And the equation that relates to that is omega is equal to 2 pi times the reciprocal of t. So here the -1 means reciprocal. And I love this. This is so nice in math when this comes together. T is equal to 2 pi times the reciprocal of omega. Isn't that awesome? It's the same thing, just with the variables flipped. So if I know the period, remember big T is the period, then I can find omega. And if I know omega, then I can find the period. We're just going to practice. None of this is in context right now, so we're just practicing the nuts and bolts of if I know one of these things, let's find the other one. So here we go. Let's do this. I'm told that the period is 10. I want to find omega. So the situation would be I'm trying to write an equation for a trig graph. So what am I going to do? I'm going to multiply 2 pi times the reciprocal of t. The reciprocal of t would be 1 over 10. That's 2 pi over 10, aka pi over 5. So omega would be pi over 5 for that one. You try the next one. Same thing, same formula. This time the period t is 3. The formula for omega is 2 pi times the reciprocal of t. So 2 pi times the reciprocal of 3. And that doesn't reduce. Did you come up with 2 pi over 3? Hooray. All right. What if we've got omega and we're trying to find the period? So this situation would be I'm looking at an equation and I want to make a graph and I want to know how wide to make my period. So same idea, 2 pi times the reciprocal of omega. So flip that fraction on its head. And this is kind of nice because the pi's cancel each other out. 2 times 6 over 5, that would be 12 over 5. You give it a shot with the next one. We get 1/4. All right. Okay, so do you feel comfortable right now? If I give you t, you can find omega. If I give you omega, you can find t. All right. And omega comes from the equation. T comes from the graph. Okay, so this next piece is what the little slip of paper you have in front of you. And I'm not going to talk too much about this today. We'll get into it a little bit later, but just go ahead and draw some dots on your paper that match up with mine. So we're going to think of sine and cosine periods as kind of a specific shape. And the shape is determined by this, I call it a little window pane. This little grid, it's 2 units tall and 4 units wide. And this little grid is going to represent one period. You're going to become very familiar with the placement of these points. These are the key points on this is basically our parent function for sine and cosine. When we connect these dots, we get the shapes that you see on the little slip of paper I gave you. And by the way, when we connect these dots, it does not form a jagged, sawtooth looking thing. Nice, smooth curves. So those are the parent functions for sine and cosine. We were just talking about this morning. My students usually come up with a pretty clever way of remembering which one is sine and which one's cosine. Do you see anything that may help you? What are you seeing? The sine kind of looks like an S and the cosine kind of looks like a C, right? Yeah. And then we are going to talk about a positive versus a negative sign. So again, this is a very engineer's way of looking at this. But you guys already know, like, if I put a negative out in front of something, what does it do? It just flips it over the x-axis. And this is the x-axis that's cutting through the center here. So a negative sign looks the same. It's just been flipped over. Same deal with a negative cosine. It's still that C shape. It's just been flipped over on its head. For all four of these, the center line here, we'll be referring to this as the center line. That's our x-axis. And where the little star is, I'm going to refer to that as our anchor point, but that's really, for right now, for today, this little star is going to be our origin. So the way that we're going to graph sines and cosines is we are going to create a frame that looks something like this. Now our frame will sometimes be tall and skinny, and sometimes it's going to be short and wide. Okay, so the size of the frame will vary, but the placement of these key points will remain the same. Okay, so we don't have an equation or anything to go with this, but this graph at the bottom of the page here, they're asking us to do a positive sine and fit it into this frame right here. So a positive sine has points at the origin, so give me a point at the origin. As we move from left to right, we go from the center, we go up to a max, back through the center to a min, and back to the center. So center, max, center, min, center. We'll connect that with a nice smooth curve. See if you can do the same thing in the next one, but this time I would like a negative cosine. So I need you to fit this pattern of key points onto this grid. This grid's a little bit wider, it's a little bit shorter. So those points are kind of the most important thing. When I grade these, I will be looking at the points to make sure your points are in the correct place. All right. Sine and cosine are what are called periodic functions. We're not quite done with this page yet. These things are called periodic functions because they repeat. So this is not the graph of a sine. This is one period of the graph of a sine function. This little framework that I've drawn here would have an exact duplicate that would be the exact same size right next to it. And there would be another one right next to that. And there'd be another one over here, and another one over here, and you get the idea. So these things go on forever and ever in both directions. So they have asked us in the instruction to fit a positive sign in there and then repeat it. So I'm going to go through and make copies of this. Now there's a fast way to do this. There's a slow way to do this. Some of you are going to figure out some little shortcuts. The way I like to do it is I just copy all of the maxes. I know that the max happens in my second part of the box here. So there's going to be a max there and there and there and there. So I just copied all of my maxes. And then I'm going to copy all my mins down here. And then my intercepts are kind of happening at these points here. So I go through and draw all the points first, and then I'll connect them all up with a nice smooth curve. So when we start graphing these things, we'll be checking our graphs using a calculator. These are the types of graphs that we're going to see. So you go ahead and do the same thing for this one. This one doesn't need as many copies because it's wider. You're going to come to appreciate when you have a nice long wide period and you have to graph it. It's a lot less work than when it's a really skinny period. If it helps you to draw the boxes, you can do it that way. Couple connections I want to make here before we go on to the next page. In this first graph here, this was the width of one of these patterns. That's going to be our period. So when I look at this graph, I can see that the period, t, appears to be 4. The period is 4 for this graph. The period is 4, and that means that every feature of this pattern gets repeated every 4 units. So if I look at this, if I know there's a max right here, there's going to have to be another max 4 units away, okay, because that's one period. If I know there's a min right here, there's going to have to be another min 4 units away. Each of these x-intercepts are exactly one period away from another x-intercept. So everything repeats every period. What would the period be for our second graph? I'm seeing 8. And while we're here, let's go ahead and practice with amplitude. What would the amplitude of this first graph be? Is it 6 or is it 3? Those are going to be my most common answers at this point. It is 3. Good. 6 is my favorite common mistake. But the amplitude goes from basically from the center to the top, center to the bottom. It's always going to be the same in both directions. So the amplitude is 3 here. In this one, the amplitude is 1. All right, feeling okay so far? All right, let's keep going. You guys are doing awesome. We're going to graph some of these things now. All right. So here we go. Can you look at this equation and tell me what the amplitude is? It's 3. Can you look at the equation and tell me what omega is? Omega comes directly from the equation. This time we got pi over 2. And if we know that omega is pi over 2, then we can find our period. You guys practiced doing that on the last page. As a reminder, it's 2 pi times the reciprocal of omega. So 2 pi times 2 over pi. Pi's are going to cancel. That's 4. So put your pen or your pencil down at the origin on your graph. And let's draw the left edge of our window pane here. So we're going to go up and down by 3. So go up by 3 and down by 3. So the amplitude tells us how far up and how far down to go, and the period tells us how wide this thing's going to be. It's going to be 4 units wide. So let's complete the outer edges of our box here. And then we're going to chop it up into those 8 little window panes. Now, they always evenly gets chopped up straight down the center like this. And then we have to cut it out into 4 equal segments, left and right. So this one's convenient because it's 4 wide, so each of those segments is just going to be 1 wide. So that's what one period is going to look like of this thing. All we need to do now is find those key points and graph it. So this is why I gave you these little slips, just so that you could refer to these and we didn't have to keep flipping back and forth. Which of our 4 graphs are we looking at here? This is a negative cosine, so we want to draw something that looks like this. This looks pretty familiar. Didn't we just do this exact graph? Or no? It was a sine. Yeah, it was a positive sine, the first one. So negative cosine has key points there. All right, and we'll make copies of that all the way across our graph and draw our nice wavy smooth graph. So however you want to do this, I like to note that my period is 4, and so I will just count from this max and I'll count over by 4s, and every time I hit another 4, I'll draw another dot. 1, 2, 3, 4. 1, 2, 3, 4. And I'll do the same with my mins here. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And another little shortcut for you. Whether you're dealing with sine or cosine, the x-intercepts are always going to be half a period apart. Our period is 4, so they're going to be 2 units apart. So I can just go across my x-axis and count every 2, and I will have another intercept at each of those points. So this part's a little tedious, but it gets us there. Once you have all your points in the right place, then go ahead and draw that nice wavy cosine. And we are going to check this one using our calculators. So that'll be our next step. If you don't have yours out, go ahead and find it. All right. Anybody need a moment still? Give me the universal sign if you need a minute. I see a couple people still drawing. I'm going to pause. I don't want you to miss the calculator part. We good to go? All right. Let's set our window first. We want to make it match this. So I'm going to go ahead and go in a window. And I'm going to set my x min to -10 because that's what I see on the left of my graph. I'm going to set my x max to +10. My x scale is how often I see a tick mark. That'll be a 1. Y min, my graph goes down to -4 and it goes up to +4. My y scale is 1 also. And then we'll go into y equals. Clear out whatever's in there and graph this thing. So -3 cosine pi over 2 times x. And we'll hit the graph button and hope that we see something that looks very similar to what's up there. Now, I'm prepared to see some of you have a little minor panic attack when you hit your graph buttons. That's okay, because I left something very important out here. And I did it on purpose because this is going to happen to you at some point. You're going to go to graph one of these things and you're going to see a flat line. Is that what you guys are seeing? Flat line? Okay, so I changed something. I didn't have this thing up underneath the camera when I did it. What do you suppose I changed to make my graph look like this? Any guesses? I'll give you a hint. It's in the mode menu. Go into your mode menu and see if you can figure out what I changed. Yeah, do you see it? So when we graph sines and cosines, we're going to be in radian mode. So change your graph to radian mode if it's not already, and then graph it again, and you should see something that looks pretty similar to what you were looking at. Is that looking better? Yeah, awesome. Something else I'll show you that can be useful to you. Some people like this, some people don't. Go into, where is it? Hit second zoom. You get to the format menu. If you've got a newer version of the calculator than I do, you're going to have some more options than I do. But I am going to turn grid on. On the newer calculators, there's more options. There's a grid dot and a grid line. This is in the format menu, second zoom. Second zoom. I'm going to turn the grid on. If you've got the newer calculator, try the different options, see which one you like. If I go back and graph now, what that does is it puts like a kind of like a grid onto the thing, right? Second zoom. This is kind of nice because it allows me to see sort of you can kind of see the grid. It looks a lot better on the newer calculators. This is one of the things that the newer calculator definitely does better than the old one, because it'll actually draw the lines in. But I like to leave those on when I'm graphing sines and cosines. So let's do one more of these. All right, so we got a sine this time. It's a positive sine. There's no number in front of that thing. What's that mean the amplitude is? 1. Omega comes from the equation. Omega is pi over 4. And then we can find the period from omega. Period is 2 pi times the reciprocal of omega. Pi's cancel out. Period is 8. Ooh, I like that. Nice wide period. That means we don't have to do so many dots, right? All right, let's draw our box. Now, amplitude's pretty small here, so you're only going to go up and down 1 this time. And your box is going to be 8 units wide. We always chop it into 4 equal segments horizontally. And this time we're dealing with a positive sign, so I'll go ahead and put those key parent points onto my graph, and then make some copies and call it a day. So, no. Every 4, I have an x-intercept. And while you guys are wrapping up, I'm just going to check this with my calculator. That looks wonderful. All right, you guys ready for the most annoying problem we're going to do all day today? If anybody has started the third one on here, number 7, gonna love this one. Any questions on 5 or 6? Okay, here it comes. This is going to be awesome. We can do it. All right, amplitude. That's easy. That's 3. Omega is pi, which means the period is 2 pi times the reciprocal of pi, which is 2. So grown, that's really narrow, which means we're going to have a million dots on this thing. So let's draw our window. We got to go up and down by 3, and this time our window is only 2 units wide. And yes, somehow we need to squeeze 4 segments in there horizontally, which means we're going to be drawing some points on sort of some half grids here. Ugh. These are the worst. All right, we got this though. We can do negative sign. On a problem like this, it really goes a lot faster to just do all of your x-intercepts at once, and then all of your maxes at once, and then all of your mins at once. If you recognize the periods too, so the x-intercepts are going to happen every half period, always with sine and cosine. It's always every half period. So that they're going to happen every 1. So I can just go straight across my x-axis and put a point at every 1. And then my maxes and mins happen every full period. So if I've got a max here, I can just count over 1, 2, and do another dot. 1, 2, 1, 2, 1, 2. So we're leveraging the idea of this thing repeats itself every period. We're just counting 1 period in between those maxes. Same thing with our mins. Isn't this fun? It's way better than graphing lines, right? Parabolas. Again, when I grade this on an assessment, I'm going to be looking for the points to be in the right place. When you draw your little wavy thing in there, if you miss some of those, it's not the end of the world. We get the right idea. All right, pause wherever you are in that process. We need to move on to number 8. Okay, if you don't get that done, that's okay. Look up here, guys. I need your attention. We got to move on. We got to move. Amplitude for this last one is 1. Omega comes from the equation. It's pi over 6, so that makes the period 2 pi times the reciprocal of that. Pi's cancel 12. Oh, I like that. I like that. That's nice and wide. Little bit of a problem though, it's too wide to fit on this thing. So here's what I'm going to do. When I get something that's too wide to fit on the graph, I'll usually draw myself a little sketch off to the side. This is my engineering brain working here. I'm going to draw myself a little model of what this thing's going to look like. I know it's going to start here at 0 on the left edge, and I know it's going to go to 12 over here. So I'm just going to figure out where these divisions are going to be. They're going to be at, well, halfway would be 6, right? And halfway between 0 and 6 is 3. Halfway between 6 and 12 is 9. So I'm going to have divisions at those spots. So when I go to draw my window pane onto my graph here, I'm not going to be able to fit the whole thing in. We're going to go up and down by 1, and we would go all the way over to 12, but we don't have enough graph to do that. But I drew myself a little model, so I know where these vertical divisions are going to go. They're going to be at 3 and 6 and 9. So I've got enough to make my graph here. This is a positive sign, so I know it's going to, I know it's going to do something like that. Ignore that little piece. X-intercepts every half period, so every 6 is going to be an X-intercept. Maxes are going to happen every full period, so every 12. So this one's at 3. 3 minus 12 is negative 9. This min here is at 9. If I go to the left by 12, 9 minus 12 is going to get me to negative 3. And that's enough for us to draw as much as we can fit into there. All right, guys, how are we feeling about graphing these things? So far, so good? We are very quickly running out of time. I want to try and get through at least one where we're writing the equation. So go ahead and flip over here. So these ones, we're just kind of doing the reverse. The tricky part about these ones is we need to find a period of whatever we're looking at. So when you look at number 11, you can kind of picture the left edge of our window pane here. Does this make you think of a sine or a cosine? Doesn't go through the origin. I think it looks like a cosine, right? And it looks to me like a positive cosine because on the left edge it's at a max, right? And I can see that it would end right here. So if I were going to put a box around one period of this, that's what I would box in. Can I get you guys to just do that for the 4 graphs that are on this page? Just find one period. The left edge is always going to be on the x-axis. For today, our left edge is always on the x-axis. And look at what's going on at that edge. Is it going through the origin? Signs go through the origin. Positive signs go up, negative signs go down. Or does it start at a max or a min? If it starts at a max or a min, it'd be a cosine. And see if you can box in one period on each of these. One of them is a little bit tricky. The last one's a little tricky because I don't think we can see a full period. Down to the wire. We're going to make it. So this is one of those things this is the piece that's probably going to take a little bit of practice for some of us. Some of you are very spatially, visually oriented, and you're going to be able to look at these and spot, oh, it starts here and it ends here. For some of us, that's not so easy. Okay, so if you're finding this a little bit more difficult to figure out where does the period end, that is something that you will get better with as you practice. Especially as you graph more and more of these, you'll get more familiar with those kind of basic shapes. All right, let's write the equation for, I don't know, let's do number 12 here. Let's do number 12. What's my period for this one? Be careful. The period is a half. You see that the period is a half? Because the scale here is 1. So t is a half. So I'm going to go ahead and put that in here. T is a half. Amplitude looks to be 3. Omega, how do we find omega? 2 pi times the reciprocal of the period. 2 pi times 2 is 4 pi. And when we identified that period, was it a positive or a negative sine or cosine? This is sine, it was going down, so it's a negative sine. So I'm going to write my equation. It's going to have a negative. I'll leave a space there. It's going to have a sine. There's going to be an x in there. We just need our 2 coefficients. Amplitude's the one that goes in front of the sine or cosine. Omega goes in front of the x. And there's our equation. All right, and then we could set up a window on our calculator and check this as well. Go ahead and do that. My x goes from -1 to 1 this time. There's a tick mark every 0.25. My y goes from -4 to 4, tick mark every 1. And the equation that I think is correct is -3. Which is, you're going to be doing some problems out of that packet, and there's some problems in the book as well. Come on back with some questions. I know we burned through that really quick, guys. Thank you for your attention. I appreciate it. Thank you, you too.